So here we're still looking at similar triangles, and now particularly the conditions that allow them to be similar. Now there are 4 conditions that could be met to allow this to happen. It could be angle, 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 and that means that all 3 angles are equal. So if this angle here was 80 degrees, in a similar triangle, even if the shape is bigger, that angle will still be 80. If this in here was 40, this angle here will also be 40, and then as all 3 angles in a triangle add up to 180, this will have to be 60, and that will have to be 60. That fits the condition of angle, angle, angle. Side, side, side means that all sides are proportional. So if this one here happened to be 2 centimetres, this one here might be 1 centimetre. And 2 divided by 1 is equal to 2. If this one here was 4 centimetres, this one here would be 2 centimetres, and 4 divided by 2 is equal to 2. And if this one down here was 3, this one might be, or will have to be 1.5, because 3 divided by 1.5 is also 2. That fits side, side, side condition. The way that one of the people that struggle with a little bit is one called side, angle, side. So 2 sides are proportional and the angle between them is equal. So if this one here was 50 degrees, and this angle here is also, now I know that's a much bigger angle than 50, but it's not drawn to scale. If that was 50 degrees, this one would be 50, and then if this side here was 10, this side here might be 5. Now I know it's not half the size, but it's just showing proportionality to it. If this side here was 12, this side here would be 6, because this one is twice the size of this one's twice the size of that, and they share the angle. The other one you see occasionally is right angle hypotenuse. It means right angle hypotenuse side. It means that in a right angle triangle, and I'm going to write this on in a second, in a right angle triangle you have one side and the hypotenuse in proportion. So if this one here was 12, this might be 6. This one here was 10, this might be 5. And if the hypotenuse and one of the sides in proportion in a right angle triangle, then they also have to be in proportion. And I've just gone that back in so you can pause this and take your notes from there. So they're the 4 conditions that we'll be looking for, and then after this it's about applying those conditions. So, as an example question, you've got something like this, write down the similarity. So go through it and think. The first thing we did was angle, angle, angle. So are all 3 angles the same? They're going to be, but we can't tell because it's not written down, so we can't use angle, angle, angle. We can't use side, 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 because even though 10 and 5 is 2, 16 and 8, this one's twice as big. We know that's going to be twice as big, but we don't have the number, so we can't use side, side, side. But we have got side being twice as big there. We have another side being twice as big there, and we've got an angle which is equal to this angle. So what is the similarity condition? Just excuse the cat in the background if you can hear it. It is side, angle, side. What is the scale factor? If this was triangle A, B, C, this was, just excuse the cats again, D, E, F, then this one here has got a scale factor of 0.5. If you want to know how to find that, it was because the value in the image is 5, value in the original was 10, 5 divided by 10 is 0.5. You can do the same thing for 8 divided by 16, you'll still get 0.5. So what is the value of A? Then it has to be 0.5 times 15, or half of 15, which is 7.5 centimetres. This is where people then get a little bit stuck from there, is find the value of the pronumeral B. Now it's hard to see that these are similar triangles, but there is one triangle here, and there is the other triangle going all the way up to the end. Now these share the same angle. We don't know what that angle is, but we know it's the same for both triangles. Now, this outside triangle is 12 and the inside one is 4. what 12 divided by 8 is, and we end up with the fact that the small triangle is, the image over the original, I've got that the wrong way around. I'll just erase that and just start that again for a second. This. We've got 8 over 12, which simplifies down. 4 goes into both, goes into 2 over 3. So this one is 2/3 the size of this. So B has to be 2/3 the size of 15. So 2/3 times 15 is going to be 10, and B is then equal to 10 centimetres. It can be difficult at times when you've got two triangles and it's hard to see two triangles. What I would do, like I've done with the red pen here, is I'd get out a highlighter and highlight them both in, even if you change colour and do one triangle then the other triangle, and then try and see which one fits from there.